I was going to respond to your absolute nonsense of a response, but it was just too much going on in there. So contradictory all over the place. So to have any real argumentation, we have to have some ground rules. We have to set some things in place. So we'll keep it simple. We've got a one mass and we want it to go one velocity. Then we want it to go 2 velocity, 3 velocity, 4 velocity, 5, 6, 7, whatever, and so on and so on. So if we have a one mass going one velocity, we have to put some force in, or some momentum in, or some energy in to make it go one velocity. Now, would you agree that if we wanted it to go twice as fast, that we would have to put more in? You know, we can't just make it go twice as fast for free. Likewise, we can't make it go 3 times as fast for free, or 4 times as fast, or 5 times as fast. We would have to put more input of energy, force, momentum, whatever you want to say. But I think you'd agree that to make it go faster, we would have to put more in. So you do understand that the energy is coming from the spring.
So, I mean, this is just, you're just saying, oh yeah, why don't you just waste everybody's time with nonsense, right? So I've made no video where I'm saying energy comes from anything other than objects where you've stored it in some way or something else. So there's no argument about this. Just a silly, fucking idiotic thing to say. Wait, yeah, like I said, just you're wasting everybody's time.
Now, you seem rather upset there that I pointed out the energy is coming from the spring. Like it wasn't important, but it was important. You said it was a waste of time, but I'm trying to drive the point home. Everybody else seems to understand. It was directed towards you, so it wasn't a waste of time. I'm pointing out that the energy moving the lever comes from the spring. Your example was a set amount of 9 pounds of force, so you agree that when we compress the spring, it's got the same amount of energy, or stored momentum, as you want to call it, but it's got an amount in, no more and no less. It's an important fact.
It's a fact, okay. So if I put the mass here, okay, and so it's the same mass, I'm just going to slide it across this lever. Now, these are experiments, I could argue that, physics should have done them, right? I shouldn't have to talk about them. They should already be done. So we should know already exactly how it proportionally changes depending on where I put this mass. So if I put it right here, right? And then we know that twice the distance, right? So this is a very small distance, but we know that twice the distance is going to be twice the velocity, right? So we know right here it's going to be twice the velocity that it was here. So it's one velocity here. We know it's going to be twice the velocity here. 3 times the distance is going to be 3 velocity, right? It's the same mass. Do you have some other theory?
In your example there, you're basically saying that where you place this mass on the lever, you can get it to go twice the velocity, 3 times the velocity, 4 times the velocity, and so on. So you've increased the momentum. So you've created free momentum there. Well done. So clearly, if there's no more energy in the system than what we started with, how is it going to go twice as fast? How is it going to go 3 times as fast? How are you increasing the momentum for free?
Well, further, then we get into...
So why would you put it out further?
Because the lever moves slower. The further I put it out, the slower the lever has to move.
So you can see there that the further you put the masses out on the lever, the slower the lever will move. Now, the further you put it out, when you launch it, if you've got it at the one distance, obviously it travels 1 unit of distance. If you put it out twice as far, it now has to travel 2 units of distance, and then obviously 3 units of distance and 4 units of distance. So if it's travelling twice the distance in a slower time, how is it going faster? The same with the 3, if we go to 3, if we go to 4, You've got 3 times the distance, 4 times the distance, and each time it's moving slower. So how can it travel slower over a greater distance but be faster? That doesn't really make sense, does it? So in answer to your question, when you move the mass incrementally in distance, how fast will it move? Given the argument I've just presented, how fast do you think a mass will move if we incrementally move it out distance-wise? Do you really think it's going to go twice as fast and 3 times as fast and 4 times as fast? Do you really think you can create free energy or free momentum?
You can't get any free energy out of the system.